Workers entered Panama's jungle carrying shovels and determination. There were no bulldozers waiting beside the excavation. Instead, dense vegetation covered nearly every working area. Torrential rain repeatedly turned pathways into deep mud. Mosquitoes carried diseases that could kill workers quickly. Meanwhile, engineers faced mountains blocking the planned canal. Thousands of workers began removing earth manually first. Steam machinery later transformed how massive excavation progressed, but machines still needed people operating them constantly. Every completed section faced another environmental obstacle. So how did workers conquer this impossible landscape? Tell us where you're watching from before we begin. Panama's geography made the canal project brutally complicated. The narrow isthmus connected two enormous oceans together. Engineers saw an opportunity with enormous commercial consequences. Ships could avoid lengthy voyages around South America. That shortcut promised faster movement between distant ports. Yet Panama offered almost nothing resembling easy construction. Dense forests covered much of the proposed route. Tropical rainfall regularly flooded low-lying working areas. Rivers crossed the landscape at inconvenient locations everywhere. Swamps swallowed equipment, tools, and temporary pathways whole. Even clearing vegetation became exhausting under tropical conditions. Workers first hacked through trees using basic tools. Fallen timber then had to be removed manually. Roots remained buried beneath the newly cleared ground. Those roots complicated digging long trenches through soil. Construction camps also needed roads and supply routes. Food, equipment, fuel, and tools required constant transportation. Railways gradually became essential for moving heavy materials. But railway construction created another enormous workload there. Tracks needed stable foundations across unstable tropical ground. Heavy rain could quickly damage freshly prepared embankments. Workers repeatedly repaired sections damaged by sudden flooding. Meanwhile, engineers studied the best route through Panama. The proposed canal could not simply follow terrain. Ships needed dependable depths and carefully controlled waterways. That requirement made elevation changes extremely important too. One major obstacle dominated the planned central section. The Culebra region contained towering ridges and hills. Those ridges stood directly across the intended route. Removing them became the project's greatest excavation challenge. Engineers calculated enormous quantities of earth needing removal. The figures seemed almost impossible for manual crews, yet construction could not proceed without clearing those heights. Workers began attacking the landscape section by section. Small teams opened initial cuts through stubborn ground. Surveyors constantly checked elevations against their planned measurements. Mistakes could redirect the entire canal alignment later. The terrain also created serious drainage difficulties nearby. Water naturally collected inside newly excavated areas. Pumps became necessary wherever groundwater overwhelmed working trenches. Rainfall added another source of unwanted water constantly. Construction therefore became a continuous battle against water. Dry ground rarely remained dry for very long. Workers often returned after storms to repair damage. Their progress depended upon weather conditions each day. That unpredictability made traditional digging painfully inefficient. Engineers needed machines capable of removing larger quantities. Steam power offered the first major breakthrough available. Mechanical excavators could attack earth much faster. They could also load spoil directly into rail cars. This created a powerful new excavation system overall. Workers operated machinery while railway crews hauled material. Other teams extended tracks toward fresh excavation zones. Each group depended upon the others constantly working. The canal was becoming an enormous industrial operation. Still, machines could not solve Panama's deadliest problem. Something invisible was already threatening construction camps. Workers began falling seriously ill without warning. Fever spread through crowded camps and temporary settlements. Deaths increased while engineers struggled understanding the cause. The jungle was hiding another obstacle beyond excavation. Before the canal could conquer mountains, workers faced disease. Steam power eventually transformed the excavation operation across Panama. Large steam shovels attacked ground with tremendous force. Their buckets removed material far faster than workers. Operators controlled these machines from elevated working platforms. Each bucket descended into freshly loosened earth below. Hydraulic mechanisms then lifted enormous loads upward again. The spoil dropped directly into waiting railway cars. Locomotives immediately carried those loads toward dumping grounds. This created a continuous cycle across excavation zones. Digging could continue while trains removed the waste. The machine still depended upon skilled human crews. Operators needed experience judging difficult ground conditions. Mechanics maintained boilers, engines, cables, and moving machinery. Firemen kept steam pressure high throughout operations. Track workers extended rails toward advancing excavation phases. Surveyors marked boundaries before machinery began cutting deeper. Laborers cleared obstacles surrounding each machine's working area. Together, these teams created an enormous coordinated system. Explosives provided another powerful method for difficult rock. Workers drilled holes into particularly resistant formations first. Dynamite charges were then placed inside those openings. Controlled blasts shattered rock into manageable fragments afterward. Steam shovels gathered those fragments into waiting cars. Repeated blasting gradually lowered entire sections of terrain. Each successful blast opened another section for excavation. Rain constantly disrupted this carefully organized operation. Water filled freshly excavated areas without warning. Mud slowed locomotives moving through unfinished railway sections. Workers sometimes rebuilt tracks after severe tropical storms. Machinery could become trapped inside saturated ground quickly. Drainage crews therefore worked alongside excavation teams constantly. They dug channels directing unwanted water away elsewhere. Pumps removed deeper water collecting beneath excavation floors. Without drainage, machinery could barely continue operating safely. Railways became the backbone supporting this entire process. Every excavated load needed transportation somewhere else. Dumping locations changed as excavation zones moved forward. Tracks therefore had to follow construction progress constantly. Crews dismantled temporary sections behind advancing machinery. Those rails were then rebuilt farther ahead. Switches allowed loaded cars to enter different routes. Locomotives hauled long lines of heavily loaded cars. Timing became important throughout this enormous operation. One delayed train could interrupt several excavation machines. A blocked track could stop an entire working section. Crews therefore maintained rails throughout difficult conditions. The scale of excavation continued increasing dramatically. Mountains produced millions of cubic yards of spoil. Every load represented another piece removed from Panama. Steam shovels made that workload physically achievable. Yet machinery introduced new challenges requiring constant attention. Boilers needed fuel and regular mechanical maintenance. Moving parts suffered wear beneath relentless tropical humidity. Operators worked around enormous machines throughout long shifts. Repairs sometimes required dismantling complicated equipment on site. The excavation system gradually became remarkably efficient. Machines attacked the ground while trains carried material. Surveyors directed progress while mechanics maintained machinery. Drainage crews kept working areas usable after rainfall. Thousands of workers supported this industrial network daily. Human labor remained essential despite increasing mechanization everywhere. Machines provided power, but people provided coordination. For the first time, Panama's mountains began retreating. Entire hillsides slowly disappeared beneath continuous excavation. The canal's planned route became increasingly recognizable below. Yet another danger remained inside the construction camps. Workers could fight rock using machines and explosives. They could not fight an invisible mosquito. Disease would soon become the project's deadliest enemy. Disease threatened workers long before excavation reached completion. Fever could strike suddenly without obvious warning signs. Yellow fever became especially feared throughout crowded camps. Malaria created another deadly threat across Panama. Workers often became sick after repeated mosquito exposure. At first, nobody understood mosquitoes carried these diseases. Many doctors blamed foul air for spreading sickness. That belief shaped early medical responses throughout Panama. Workers therefore remained exposed despite growing death rates. Hospitals filled while construction continued around them. Families received terrible news from distant work camps. The human cost became increasingly difficult to ignore. Poor sanitation made conditions even more dangerous. Stagnant water collected around buildings after heavy rainfall. Open containers created additional breeding places for mosquitoes. Drainage ditches frequently became clogged with debris nearby. Workers needed cleaner surroundings around their living quarters. Medical teams gradually recognized environmental conditions mattered greatly. Investigators began studying where mosquitoes gathered most. They discovered standing water supported enormous mosquito populations. Removing those breeding areas became increasingly important. Workers emptied containers and improved drainage around camps. Crews cleared vegetation surrounding important residential areas. Buildings received screens protecting windows and sleeping spaces. Fumigation became another weapon against indoor mosquitoes. Special teams treated rooms before workers occupied them. These measures gradually changed conditions throughout construction camps. Sanitation became part of construction itself thereafter. Drainage crews attacked stagnant pools across settlements. Water supplies received greater attention from administrators. Waste disposal systems became more carefully organized. Workers received cleaner living environments than earlier crews. Medical facilities expanded as understanding of disease improved. The transformation required enormous organization across Panama. Scientific discoveries eventually changed the entire strategy. Research connected specific mosquitoes with yellow fever transmission. That discovery transformed public health efforts dramatically. Officials could finally target the actual disease carrier. Mosquito breeding grounds became primary targets for elimination. Workers drained pools and filled depressions containing water. Vegetation received regular cutting around important settlements. Buildings received tighter protection against invading insects. Sleeping quarters became safer through screened openings. Fumigation teams treated buildings throughout affected areas. These efforts dramatically reduced dangerous mosquito exposure. The impact reached far beyond medical statistics. Healthy workers could remain longer at construction sites. Projects faced fewer interruptions caused by widespread illness. Hospitals gradually experienced less overwhelming pressure. Workers could focus upon excavation rather than survival. Construction productivity improved as health conditions stabilized. The canal project finally gained another powerful advantage. Panama's canal emerged through machinery, labor, and sacrifice. Workers conquered jungle, mountains, rainfall, and deadly disease. Their methods transformed one impossible vision into reality. The finished waterway permanently changed global maritime transportation. Subscribe for more forgotten engineering stories from history.